Alright, so today's lesson is on solving some more equations. These equations are not necessarily going to be quadratic equations, but they are going to take a form similar to what we've seen a lot of quadratic equations look like. And so we're going to use those same ideas to try and solve these types of problems. So if we look at our first one, we have a polynomial of degree 4. One thing to keep in mind when you're solving polynomials is that the degree of the polynomial tells you how many roots or how many solutions that equation has. So in this case, since it is a degree 4 polynomial, there are going to be 4 solutions to this problem. So what do we do? Well, if we can factor this, that will help us get to our solutions. So if I think about trying to factor here, I've got an x to the fourth, and this middle term is x squared. So I'm going to be breaking that down into a couple binomials where the first terms are going to be x squared terms. But before I do that, I'm going to go ahead and use my process of multiplying a times c. So 2 times 35 is 70. And I'm looking for two numbers that multiply to be 70 and add up to be negative 19. Well, it turns out that that would be negative 14 and negative 5. And so if we split the middle term here, we have 2x to the fourth minus 14x squared minus 5x squared plus 35 equals 0. We're going to now group and take these first two terms and group them. If I look at a greatest common factor in that group, I would have a 2x squared, and that leaves me with x squared minus 7. If I look at my second group, I can take out a negative 5, and that leaves me with x squared minus 7. So then my factors would be 2x squared minus 5 and x squared minus 7. So once again, if I have the product of two quantities here and that product equals 0, that means that if either of those quantities are 0, then that side is going to equal 0. So I'm trying to find ways or find values of x's that will make 2x squared minus 5 equals 0, and values of x that will make x squared minus 7 equals 0. So for this first one here, I would add 5 to both sides. I've got 2x squared equals 5. I would divide both sides by 2, and I get x squared equals 5 divided by 2. If we're solving here, we would need to take the square root of both sides, and that leaves me with that x can equal plus or minus the square root of 5 halves. Over here, I'm going to add 7 to both sides of the equation, so I have x squared equals 7, and once again, I'm going to take the square root of both sides and get that x equals plus or minus the square root of 7. And so those are 4 solutions to the problem: plus or minus 5 halves, and plus or minus the square root of 5 halves, and plus or minus the square root of 7. And another equation that we have here, this one is a quintic equation because we have x to the fifth, so we have a degree of 5. We want to set this equal to 0, so we want this first term here with the highest degree to have a positive coefficient. So I'm going to subtract the 39x cubed from both sides, so that all 3 of those terms are on the left side, and I now have that equal to 0. If I'm looking for a common factor here, looks like 3x is a common factor, and that leaves me with 5x to the fourth minus 13x squared plus 6 equals 0. Want to try and factor this trinomial, 5x to the fourth minus 13x squared plus 6. So I multiply a times c, and I have 30. So I'm looking for numbers that multiply to be 30 and add up to be negative 13. Got to be a little careful here. You might think it's something like 15 and 2, but we've got a negative 13 and a positive 30, so it actually needs to be negative 10 and negative 3. So those two will multiply to be positive 30, but add up to be a negative 13. So if I split my middle term, I've got 5x to the fourth minus 10x squared minus 3x squared plus 6 equals 0. If I do my grouping, GCF in the first two terms here would be a 5x squared, and that leaves me with x squared minus 2. GCF from the second group here would be a negative 3, and that leaves me with x squared minus 2. So my factors are this 3x, which was my greatest common factor, the 5x squared minus 3, and the x squared minus 2. Remember, this was a polynomial of degree 5, which means there are 5 solutions. So each quantity I have here, if I set equal to 0, since they all have a variable involved, so 3x, what would make 3x equal 0? Well, x value of 0 would make that happen. So that's one of our solutions. Also, what would make 5x squared minus 3 equal 0? If I add 3 to both sides, I have 5x squared equals 3. I divide by 5 on both sides, so now I have x squared equals 3/5. And when I take the square root of both sides, I get that x could equal plus or minus the square root of 3/5. Final one here, if x squared minus 2 equals 0, and I solve for that, I add 2 to both sides, x squared would equal 2. I take the square root once again of both sides and get x equals plus or minus the square root of 2. And you can see there, because of the plus and minus values on those second parts there, that there are a total of 5 solutions. Okay, so probably our most difficult problem, and the one that is going to be something you've never seen before probably, is this: 3x plus 4 quantity squared minus 9 times the quantity of 3x plus 4 plus 14 equals 0. So I'm going to try and solve this without expanding it out, which means I'm not going to multiply everything out and then try and solve from there. So what can I do? If I think about trying to do somewhat of a substitution here, what I'm going to say is I'm going to take A, and I would like to say I want A, let me write it this way. I'm going to say let A equal 3x plus 4. So I've got these quantities of 3x plus 4 that occur in my problem, but I'm going to try and kind of not think about 3x plus 4 and instead replace it with an A. Well, if I do so, if this is 3x plus 4 squared, quantity squared, then if I'm replacing that with A, I really have A squared. Minus 9 times this 3x plus 4, but I'm letting A equal that, so what I have here is minus 9A plus 14 equals 0. Well, now I've got a quadratic that I can factor. And so if I factor it, I get A minus 7 and A minus 2 as the two factors. And if I set those equal to 0, I get A equals 7 and A equals 2. But what I'm really interested in doing here is not solving for A. A was not part of my original problem. I'm wanting to know what values of x make this equal to 0. So now I need to resubstitute in 3x plus 4 for that A. And so what I'm going to do now is A is now going to become that 3x plus 4 again. And so I have 3x plus 4 equals 7, and I have 3x plus 4 equals 2. And so when I solve that, I get 3x equals 3. subtracting 4 on both sides. So x equals 1. And then over here I'm going to subtract 4 on both sides, giving me 3x equals negative 2. And when I divide both sides by 3, I get x equals negative 2/3. So remember, we're solving for the variable we started with. We're trying to find solutions for x here. And I have 1 and negative 2/3. In order to make this a simpler problem, I did a substitution, substituting in a for this 3x plus 4 quantity. Working my problem out there makes it a lot easier. And then I resubstitute, change it back around, and in the end I can solve for those values of x. So you'll have some problems like that in your homework to practice doing that very same thing. Last problem here, once again, is a grouping problem. So it is not a quadratic, but we can do the same type of thing we've done before by using factoring by grouping to solve here. So if I take my first group of 2x cubed minus 8x squared and I look for a greatest common factor, I've got 2x squared there, and that leaves me with x minus 4. And then my second group, I can take out a negative 5, and that leaves me also with x minus 4. So my factors here are 2x squared minus 5 and x minus 4. If I solve each of those, 2x squared minus 5 equals 0, and x minus 4 equals 0. This one's pretty easy. This one comes out to be x equals 4. Here I'm adding 5 to both sides, so 2x squared would equal 5. When I divide by 2, I get x squared equals 5 halves. And when I take the square root to solve for just x, I get that x equals plus or minus the square root of 5 halves. And so I have two solutions right here and one solution here, giving me a total of 3 solutions. If you look back at the original problem, it had a degree of 3, and so we should have those 3 solutions. So we found that. All right. So those are the only examples that we have for these notes. There's your homework assignment.